Welcome to a lesson with Dr. Powell. Let's take a look at an instance of partial fraction decomposition, which is actually pretty quick when we can use something called the cover-up method. And why does it work? And how does it work? And what is it? Well, let's do something simple with a numerator of 1, okay? And let's do like x, let's do something like x plus 1 and x minus 1 even, all right? Notice how these two fractions are don't share any common factors. They're different from each other, um, relatively prime, coprime, or whatever you want to call it. So we can actually rewrite this as, now since this degree is 1, we have a constant on top of it. So we can say like a over x plus 1 plus b over x minus 1. And the goal is to rewrite this as the sum, some constant over x plus 1 plus some constant over x minus 1. And what would those constants be? Okay, let's think of it this way for a minute. All right, now, if we were to multiply everything by x plus 1 on both sides, you'd have a plus b x plus 1 over x minus 1 is equal to, and then x plus 1s would cancel over here. And so you'd be left with 1 over x minus 1. Now, why is this useful? Because if you plug in -1, look what happens. This goes away. And we get a is equal to 1 over x minus 1. Well, that's the same thing as covering up this x plus 1. See how we cancel it by multiplying both sides by x plus 1? But that's the same thing as just covering up the x plus 1 portion. Just cover it up with your hands. So just take this and cover it up and ignore it for a minute, and then just plug in what would make this 0, which is -1. So plug it in, right? Because then you'd have a equals when you plug in. So when you plug in -1, this part's 0, but this part is 1 over -2, so you get -1/2. And that's exactly what a is. So we could actually get that just by looking at this, by thinking, okay, what makes x plus 1 0? It's -1. So just cover this up and plug in -1 to the other part. So you have 1 over -1/2. Hey, that's what goes on top of x plus 1. So -1/2 over x plus 1. We did that without actually writing out anything, and just very fast. Cover-up method can work nicely, especially when you have parts that are relatively prime to each other. So -1/2 over x plus 1. Plus, okay, and let's look at this other, what we could do over here. So x minus 1, what makes it 0 is 1. Let's just cover this up and plug 1 into the rest. It's 1/2. So we have plus 1/2 over x minus 1. We have just successfully taken this and rewritten it as a sum of these simpler fractions to integrate. Now, in the integration here, the antiderivative of this portion is -1/2 natural log of absolute value of x plus 1 plus 1/2 times the natural log of absolute value of x minus 1. And then you just add c, and then we're done. We just integrated this, find the general antiderivative, using this little fun cover-up technique associated with partial fraction decomposition. It works great when things are relatively prime to each other. And especially if these degrees are 1, we can just kind of go ahead with that. If they're not 1, you can still use a version of the cover-up method, and we'll see an example of that in another video. Thanks for watching.